channel Non-Star Continuous Knowledge Excellence. My name is Karuna Singh. In this video, we will get to know about UV, visible spectroscopy theory and laws of spectrophotometry. So now our expert Professor Himadri Bibo Hidar, who is associated with National Center in Agro-Nanotechnology, Terry Diker Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. We'll explain you in detail about this topic. So to get complete information, watch full video without skip.
When you pass light through a material, the material absorbs certain amount of light, and that is proportional to the length of propagation. That is L. The amount of light that is absorbed is proportional to the length of propagation, also proportional to the concentration of the sample. Whether you have a sample with a concentration 1 gram per ml or 200 grams per ml, that will affect the absorbance. Okay, so the amount of light that will absorb will depend on the concentration and the length of propagation. So you put a constant of proportionality, then you have a relationship absorbance equal to some constant, which is called the extinction coefficient, concentration and length. This is a very standard thing that you see in UV visible spectrometry in everyday life. Okay, so that is reorganized into the famous called the Beer-Lambert's law. As you increase the propagation length, the intensity of the transmitted light decreases exponentially. Okay, from there a relationship found out here, and people use that relationship to find out from the absorbance, the concentration of the material. This is a very standard thing, and it's done routinely in many different labs. So your absorbance linearly proportional to the concentration of the sample from the Beer's law itself, what we discussed 1 minute ago. All right. So this information stays in the background now for us. We will use nanotechnology, and we'll use the optics or optical properties of the nanomaterials and try to detect the analyte by inducing a color change, because we want to visual inspection, not even visual spectrophotometer, visual. So the principle is going to be the following. We have a substrate. This substrate is a nanoparticle, S. Okay, this is a nanoparticle. I expose it to an analyte. This analyte can be a microbe, heavy metal ion, can be a bacteria, can be a biomarker, can be a pesticide molecule, can be a dye molecule. It can be anything that I want to detect. A is want to detect. It's called the analyte. I put my nanoprobe, which is the nanomaterial, for instance, gold nanoparticle, in a solution of analytes.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
They will bind with each other and make a complex of the analyte and substrate with certain concentration. Okay, this is all as simple as this. Now, once this complex has been formed, I want to observe this complex optically, through spectroscopically, optically. Now, I have already given you enough information to convince you that now we are in a stage that we will be able to see the changes through our naked eye. Again, this is again reproduction of the Beer-Lambert's law plot. Same thing, if you change the concentration of the substrate, for instance, gold nanoparticle, their absorbance will increase. If you do the UV visible spectroscopy measurement, okay, quantify it. With your eye, you cannot quantify it. You can only see changes and give a first line of information that yes, something has happened. Then you do a UV visible spectroscopy, quantify it, how much material is there. Okay, this is the quantification part of it. Okay, so we are still on the visual observation. Okay, now same thing I have put in a different way now. We have the S here substrate, which is the nanoparticle. Suppose this is a gold nanoparticle. This is my analyte. It can be any analyte. Heavy metal, can be a dye, it can be a pesticide, it can be a microbe, it can be a biomarker, it can be a nucleotide, it can be a protein, it can be anything. Now, if I mix these two things here, two things will happen. There are two possibilities. Third possibility, of course, they don't react at all. That's not possible. So they will react. So one is these analytes come and get deposited on the surface of the nanoparticle. Like this, they form a corona around it. What will happen? If they form a corona around it, the properties of the nanoparticle will change, because here the interface of the nanoparticle was with water, for instance. Here it was dispersed in water, so there was water around this. The interface was water. Remember the interface data I showed you earlier for gold nanoparticles: oil, water, air. Now the water interface has changed and the analyte is created a new interface here. If it has created a new interface, correspondingly the spectrum of the light will shift further to the right, because the particle size will appear larger now. Okay, that is one possibility. Case number two, this analyte will induce an aggregation of these nanoparticles. Large clusters of the nanoparticles are formed, induced by this analyte. So this analyte sits here, helps it to form clusters like this one. And this is much, much larger than this. Much larger than this one, aggregated state. So therefore, this will induce much higher shift in the wavelength compared to what will happen here. So both these cases can be detected through a change in the color. If you look at the sample, if you mix these two things together, you see a slight change in color. Then this is surface coating process is active there. You see a large change in color. Then you see the aggregated structure has taken place. Once you have done a calibration process, then it will be possible for you to identify the analyte that is there, which has created this phenomena here. That is the whole thing.
I hope you liked this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium organized the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. The very first one is mentorship, second, patent commercialization, third, joint product development, fourth, research projects, fifth, consultancy services, sixth, nanomaterials for your research projects, seventh, training programs or customized training programs, eighth, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you. For more updates, subscribe to our channel, click the links shown on the screen to stay connected.